So in this example, we want to look at an example of straight line depreciation. So the principle we want to focus on is to just look at the function with a variable. Here our function is the value of a firm's delivery truck, and the variable is t, representing years. So it's been estimated that we have the value of the of the delivery truck equal to 65,000 minus 750 t. And here are the questions we want to answer. So for that first question, what is the initial cost? Well, we want to understand what is the value when t is equal to 0. So to solve for that, we just take 65,000 minus 7,500. Now because t is 0, everywhere we see a t, we're going to put the number 0. And then that tells us that the value at time 0 is just 65,000, which is the initial value, which we can assume then is the initial cost. Next question is, what is the value after 4 years? Well, there we're asking, what is the value when t is equal to 4? So this is equal to 65,000 minus 7,500 times 4. And so to break out a calculator real quick, would be 7,500 times 4 is equal to 30,000. So we get 65,000 minus 30,000. So therefore the value after 4 years would be 35,000. And that's our answer for number 2. Now the next question is, when is it worn out? What we're asking here is not the value at time at some period, but we want to find when the value at some t is equal to 0. Because that's when it's worthless, when it's worn out. So we just set 0 equal to 65,000 minus 7,500 times t. Here we want to find what t is, the time in which the value is 0. So therefore I add 7,500 to each side. So I'll get 7,500 t is equal to 65,000. I divide by 7,500. All right, then I get 65,000 divided by 7,500. And I get time is equal to 8.67. I'm going to round to the hundredth. So that is the time when it is worn out. So after 8.67 years, this delivery truck is now worthless. Lastly, let's draw it on a graph. So here I have what's normally my x and my y, but I'm going to change this to match the information given. So my y in this case is value of the truck, and my x is time. All right, so I solved over here. When time is 0, value is 65,000. So this is in our slope-intercept form. So I know my y-intercept is 65,000. Well, the slope is going to be a negative slope because of the negative 7,500. And this tells me when my value is 0. Well, I just solved that out. So this is 8.67 and has a slope of negative 7,500. So that's how I'd answer number 2. Now to take that a next step to look at a break-even analysis. So here we have a firm's revenue and cost function. We have total revenue equals 45Q and total cost is 560 plus 9Q. Now we're going to test a little bit of our economic knowledge here to understand what is fixed cost and what is variable cost. Well, a fixed cost is a cost that you incur regardless of how much quantity you produce. A variable cost is the cost dependent upon the quantity. So if I look at my total cost, I have this term 560, which is independent if I produce 1 unit, 0 units, or even 1,000 units. This 9Q is the cost I incur depending on how much I produce. So my fixed cost is 560. My variable cost is 9Q. Now the next question we want to ask is, what is the price the firm is charging? Well, this is testing the principle of total revenue is equal to price times quantity. And if I know that, then I can just look at total revenue and I can recognize that total revenue is equal to 45 times Q. So Q is the quantity, and therefore 45 is my price. So to answer that question, the price the firm is charging is just 45. And then what assumption is made about competition in the market? Well, this is assuming that price is given, that they are price takers, meaning that in a competitive market, they're given the price. Now, lastly, what is profit when Q is 100? Well, this is testing the principle of profits equal total revenue minus total cost. Well, I have my equation for total revenue, and I have my equation for total cost. And that just means now I'm given 100, so I just plug that in. So my profits as a function of quantity is equal to 45Q, which is my total revenue, minus 560, which is my fixed cost, plus 9Q. Now make sure I put that in parentheses because I'm going to subtract all of that. Well, now I know that I'm going to look at when Q is 100. So this is 45 times 100 minus 560 minus 9 times 100. So I'll get 4,500 minus 560 minus 900. And I get 4,500 minus 560 minus 900 on my calculator, and I get 3,040. So these are my profits when quantity is equal to 100. Now let's go to this other question here. What is the break-even point? The break-even point determines when profits equal 0. So again, we're going to rely on this information here, that profits is equal to total revenue minus total cost. Well, if profits are 0, then that just implies that total revenue equals total cost, because if profits are 0, I can add total cost to each side, and the break-even point is when total revenue is equal to total cost, or the point at which I first start making a profit. So with this information, I can do 45Q is equal to 560 plus 9Q. And now I just have to solve for Q. So I subtract 9Q from each side. I get 36Q is equal to 560. I divide each side by 36. And I get Q is equal to 15.56, rounded to the nearest 100th.